All right, so I'm going to show you for my Zoom friends. I'm going to show you, we're going to talk through a couple of things before I show you the actual math practice itself. Let me bring this over and then let me share with you. Okay, so this is a phase change diagram. We have done these. You've done, oh, you girl, just, sorry about the monkey cam. Zoom. Okay, so here's a phase change diagram for water. So there are a couple of things that we've got to point out here that I need to make sure that you see, that I show you before we get started talking about the calculations we're going to be doing today. So Zoom, here's the deal. I want you to listen, and then you can take a picture of this when we're finished. For my in-person kids, what I need for you to do is as I label this thing right here, you're going to want to label with me because that's going to help you with the math that we're about to do. Okay, so here's what's going on here. So this is our phase change diagram. We have ice, water, and steam. The other, so the ice is solid, right? Water is liquid, and steam is a gas. Now, here's the thing. We're going to be breaking this up just a little bit. So the practice problems that are on your document, you're only going to do about half of them today. So we're going to be doing one practice problem together, and then you'll have 2 to complete on your own. Tomorrow, we're going to do one practice problem together and 2 to complete on your own. Okay, so the first thing is that this section right here that shows ice, I'm going to put an equation. And again, if you're in person, you need to be making sure you get this down as well. So on this line by itself, Q equals M times C times delta T. That's that specific heat formula that we started working on the week before spring break. Now, this line right here, this is where the phase change is actually happening. Okay, that's where the phase change is actually happening, is right here, going from ice to water, from a solid to a liquid. So we've got a different formula that belongs here. Q equals M and then delta H. We have not actually talked about delta H yet, but we are going to talk about it today. And then I'm going to put something else under here, delta H, and then FUS. Let me bring this down just a little bit. And then here. So Zoom, like I said, because you don't have printed copies of this, I'm going to let you take a picture of it in just a second, but we're going to write a couple of little things down at the bottom. And then you can take a picture that way that you've got it all there. Okay. So if you notice one thing while you're still writing is that all of the places where there's one phase of matter, solid, liquid, gas, they all have the same formula, and it's that specific heat formula. The Q equals MC delta T. Here, here, and here. Now, what we've got going on with our phase changes is that we've got Q equals M times delta H. Well, there are 2 different types of delta H. Okay. Delta H is the change in heat. But when we're going from a solid to a liquid, it's something called the heat of fusion. And when we go from a liquid to a gas, we call that the heat of vaporization. And we're about to write some of that stuff down here. All right. A couple little things to jot down for you. First thing. Sorry, trying to make sure you guys can see. Make sure I can write. All right, so what we're going to be calculating today is called latent heat. Latent means like, latent heat means like, the word latent means not late, but sometimes leftover is what latent means. So here's what latent heat is. It's the heat required to turn a solid into a liquid. Ooh, that's an arrow. That's an arrow. Solid to a liquid. Or liquid to a vapor. And then without so without changing the temperature. This is scribbled. All right, so I'm gonna let you guys out here get that down real quick. Yeah. Were you on FaceTime with the person that you were? Okay, so the heat of fusion is equal to, and the heat of vaporization all right, Zoom, get ready with the camera or something to take a picture because we're done labeling this, but you're gonna definitely need it, okay? So y'all hang, just a second. Let me see. Whoa. Okay. So Zoom, go ahead and take a picture of that real quick, please. Please and thanks.
We had a full-blown rush wrapped around down to the at like 9:45.
Nope. Nope. All right. Let's talk about the math real quick. So basically, latent heat is, it's not heat that's changing. The heat is changing, the temperature is not. When I say heat, keep in mind, I mean heat energy. And so the energy is changing, but the actual temperature itself is not. Okay, so I need you guys to make sure you have out the practice page. We're gonna come back to this quite a bit while we're doing our little practice problems. So you need to make sure that you stay with me because there are a couple of little things we got to talk about while we do this. So it wants to, basically what we're going to be calculating is how much heat do we need to turn a solid to a liquid and a liquid to a gas. We're going to do liquid to gas tomorrow. So today is just solid to liquid. So this is the first page of the math practice. And you'll be comforted to know that this is one problem. So all this stuff up here is stuff that you're going to be using, and you're going to see it for every single problem. All right. So let me walk you through what we've got here. We've got the specific heat for some stuff. And remember, specific heat, and if you want to label this on your paper, you can. Feel free to. Where did my pens go? Specific heat. This is in that Q equals MC delta T that we started working on last week. This is going to be your C value right there. So Q equals MC delta T. That's where the C comes from, is right here. And then we have our latent heat values. So we've got heat of fusion right here. Remember, fusion is to go from a solid to a liquid. And then we've got the heat of vaporization, which is to go from a liquid to a gas. So that's what's going on here. Then we've got two formulas. So I'm going to show you how to do this. The first thing is the specific heat practice that we did. That's really the first step. So if you've been understanding that stuff, then you're kind of good to go. The only difference is every single place on this little chart right here. So this, I'm going to label this 1, 2, and 3. And I'll show you why in a moment, because we're going to be doing 3 different calculations. This is going to be 1, this is going to be the second one, and this is going to be the third. So the first thing we need to do is we need to calculate specific heat, the energy for specific heat for ice. So here's what we're going to do. This is what we're going to be finding. So we don't know that yet. But we can go ahead and fill in M and C, and then I'll talk about delta T in just a second. So example number 1 says, how much energy is required to change 100 grams of ice at 30 degrees C to water at 60 degrees C? I don't want you to get ahead of me. And here's why. The calculations for temperature are going to look a little bit different, just a little bit, because now we're going not just from, like, we're not just heating something up. We're going from one state of matter completely different to a completely different one. Okay, we're starting with one, going to another. That's what we're about to do. So the first thing we can do is we can fill in mass. So it says 100 grams. So under mass, we're going to put 100 grams. Now, Zoom, if you would like to do this on paper instead of typing it in your document, you can totally write this stuff down on a sheet of paper. And then you can turn in pictures on the Google Doc, okay? Now, the C value. Remember that I said that we could find that C value up here. We just got to pick the right one. Well, luckily it tells us that we're working with ice. So here's ice, and here is the specific heat. I am not going to bother writing all of the units. These guys right here, that's too much, honestly. So what I'm going to do here is that for ice, up in our chart, it is 2.00. So that's what I'm going to write there. All right, so I need you to see something. Okay. Here's the thing. I numbered these for a reason, okay? The first thing is when we're trying to find delta T, the change in temperature, we got to keep in mind that at a certain temperature, things are going to start changing a little bit. So for example, this is ice all the way through this line right here. Starting from here, all the way up to there, it's ice the whole time. And at this point right here, where those two lines meet, that's going to be your melting point, because we're going from a solid to a liquid. But what I want you to notice, and this is something honestly, you should just memorize this, okay? The freezing point of water in Celsius is just 0 degrees. So here's the thing. When we're about to calculate delta T, it says that we start off at negative 30 degrees. And then we're going to make our way all the way up to 60 degrees. So let me show you something. If negative 30, so here's 0 degrees, that means negative 30 is somewhere down here. Doesn't really matter where, but it's down here. Now, if we go all the way up to 60 degrees, which would be about right about here or so, if we follow this across, now we're not in ice anymore. We're in water. So we have to be careful. When we're going from one state of matter to another, you have to calculate up into its boiling point or its vaporization point, or sorry, melting point or boiling point. So what I mean is, if we started at -30, let's just assume that -30 is right here. Okay. The temperature change, because the problem says we want to calculate this stuff for ice. That means that we can only go up in the temperature until we don't have ice anymore, or until it starts to change. So when we go from -30, we can go up, 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 up. Here's where things change. So our final temperature of the ice is going to be 0 degrees. Okay. So instead of doing 60 degrees, because it says that we went from -30 to 60, instead of finding the difference there, we have to do just where it was up to the melting point. So we started at -30 degrees, but then the melting point of water is 0 degrees. So how much did the temperature change in between there? By how many degrees? If we started at -30 and we rose up to 0 degrees. How many y'all think? If you have -$30 in your bank account, and then all of a sudden you look at your bank account, it's at $0, you added $30 to your account. So here, our change in temperature, we went from, so look, final minus initial, right? Our final temperature of ice, not of all of everything, just the ice. We ended up at 0 degrees. So final minus your initial, and your initial was -30. What do you do if there's two negative signs like that? Y'all know? Yeah, they turn into a positive. So our change in temperature is 30 degrees. Now, the good news is, if you have filled in this part, the actual math is very easy. You're just going to multiply these three things together. So 100 times 2 times 30. So our answer here, look at some quick math. 2 times 30 is 60. 60 times 100 is 6,000. So that's what the Q is for the ice. All right. Now we got to figure out our stuff for water. All right, so here's what's going down with water. We're still going to have 100 grams for our mass. Still going to be the same thing. Okay, still same thing, 100 grams for mass. Our C now is different though, because remember we find our C up here, and this time we're dealing with water. So water is 4.18. I definitely don't think they're going to switch you with that. Those are how many school days left we have. They might let you. I don't know. I'm not in control of it. All right. All right. So moving on. We got to find our delta T. So here's the thing. In the problem, it said we started at -30 and we ended up at 60. So when we did this one, we went from -30 to 0. So now that here's where our water is. This is where water starts. So we're at 0 degrees where it starts. And then we made it all the way up to 60 degrees. So let's assume that this is 60 degrees right there. So if we went from 0 to 60, our change in temperature is going to be 60 degrees. Does this make sense? Yeah. Yeah? Okay. Awesome. So good news, again, is once you have these written down, we're just going to multiply them together. Bye. What happens when you don't do your work? When you were there, yeah, 100%. Yeah, those are there from last year.
I'm mad. He just
On the
rolled
first
up.
page?
How you feel?
All right, so listen up. We have 100 times 4.18 times 60. So when you put this in your calculator, you're gonna get,
A second. I forgot how you guys, how did you get 60?
okay, so here's how we got 60. So the problem says that we went from negative 30 degrees to 60 degrees. The problem with that is that we went into two different states of matter during that time.
Right.
Because here's if we start at negative 30, if here's negative 30, sorry, one second. If here's negative 30, we had to come all the way up to 0. That's where ice is. But then we also, it changes from ice to water. So we have to calculate them separately. So right now, we first did ice, and we went from negative 30 to 0. So that was 30 degrees of temperature change, delta T. And then from 0 degrees, which is where water starts, all the way up to 60 degrees, which is where the problem tells us that we ended up. So that's how we got 60.
Okay.
So there's our answers there. So the last part is, so this is spot number 1 on the graph. This is spot number 3 on the graph. So now we got to do spot number 2. Okay, because remember I labeled. So now we got to figure out what's going on here. Since there's no temperature change, we cannot use the same formula because there's no change in temperature during a phase change. So we can't do a delta T if there's no change in temperature. So what we do instead is we use this this little formula right here for latent heat. Q equals M times delta H. The good news is delta H, either heat of fusion or heat of vaporization, they give it to you. Unless you're trying to calculate it, they give it to you. So our mass has not changed the whole time because the problem told us 100 grams. The heat of fusion is when we go from a solid to a liquid. So we're going to look up here in our little chart, our little box, and the heat of fusion for water is 334 joules per grams. So down here, heat of fusion, we're going to put 334. Sorry, it's sideways. So now you just multiply these together. That's it. So like I said, I know that there are a lot of parts to the problem, but they're all basically separate problems. It's like part A, part B, part C. And then this part right here, which we're going to get to in just a second. We add all of them up. That's all you got to do. So here, the Q of ice was 6,000. Plus the Q of water, which was 25,080. 25,080. Plus our heat of fusion, our latent heat is 33,400. Like that. I mean, how you gonna make me look out like that? No, it's not. I think that speaks more about you than her. Your character is who you are when no one's watching. I'm just saying. I'm just saying. Who? Who you have not? No, you used to be here, yeah. All right, there's your answer right there. That's the total Q. We just added up all the different Qs that we calculated. So that's the whole problem. So basically what we did was we calculated the energy to change the temperature of ice. Then we calculated the energy to calculate the change in temperature of water. And then we calculated the amount of energy that's needed in order to change it from ice to water. That's just what we did. Okay, so how much energy to warm up the ice? That was the first thing. Then how much energy to warm up the water? And then the last thing was how much energy to change it from ice to water. That's exactly what we just did. Okay, what kind of questions can I answer for you? Are there any questions I can answer for you? Okay, here's the deal. You are not going to do example number 2. That's on the next page. So it's page 2 of the digital document, and it's the back of page 1 for you guys. We're going to do that example together tomorrow. Now, if you look at the 3rd page of the document for you guys, upside down, it says latent heat problems at the top, and then it starts with number 1, just like here. You are only doing number 1 and 2 today. Those are the only problems you have to complete today. That's it. Here's the thing. I would definitely recommend that you have something like this that we filled out in front of you, even though it lays it out for you. Q equals M times C times delta T. Same thing here, same thing here. The only thing that you need to be very careful of is what's happening with the temperature. Okay, so if you're starting at ice and then we're going to water, and those are our temperatures, what's the freezing or what's the melting point of water in Celsius? 0 degrees. 0 degrees, which means that for here, we have to go from -10 to 0 for ice. And so we went from -10 to 0, and then we got to go from 0 degrees to 50. For any of these problems, you're going to have to stop at 0. It's like playing Monopoly. You got to stop at 0. So if it's negative temperature, you go up to 0. That's the first one. And then after that, that's the second temperature change. So here, if we started from -10 to 0, that's a change in temperature of 10. And then it says that we went all the way to 50 degrees. So when we went from 0 to 50 degrees, that's a change in temperature of 50 degrees. Okay, so I did that one for you guys. And yeah, I'm going to, here's the deal. You guys out here, go ahead and start working, please. My Zoom friends, folks. Thank you very much. I never asked, he offered. Yeah. Zoom, I'm going to take attendance, and then what I want you to do is I do want you to stay on until you finish at least one of them, and you're going to check your answer with me. Okay. In the chat is totally fine. But go ahead and start working on these, and if you get stuck, you need to ask. Okay. If you get through one problem and you feel like you can do the second one on your own, then leave. If you get through the first problem and you're like, yeah, I guess, then stay in until you're done. That way that you can ask questions. Okay.